Hi everyone, welcome to the California Advanced Homes Program webinar on the 2019 Residential Code and beyond. Today we will provide an overview of the changes you can expect to see in future code cycles, and Scott will also give tips on how to apply these specifications to homes under the current code and achieve greater savings. If you have a question, please enter it in the questions bar on the panel on the side of your screen. We will pause periodically to take questions throughout the presentation and begin at the end. This presentation is being recorded and we will send you a link to the recording as well as the slide deck this week. My name is Allison Whitwer and I am on the CAHP program team. My colleagues and I work for TRC and we implement the program on behalf of PG&E. Any inquiries or correspondences with the program will be with us, but PG&E is the source of the incentives and the vision behind the program. Before I hand the presentation over to Scott, I want to launch a poll to see who is on our webinar today. And you can select multiple choices if there are different people in your group. So please fill that out. I'll give about 30 more seconds. Okay. So it looks like we have mostly energy consultants with us today. We also have first raters, builders or developers, utility representatives and building officials, and architects. Thank you for taking that poll. So our speaker today is Scott Blunk. He's the program manager for CAHP and CMF&H. He's been in the industry for 15 years. He's worked as a contractor, HERS rater, energy consultant, and an engineer before working on program implementation. So I will give the floor to you, Scott.
All right, thank you, Allison. So I understand I'm a little softer than Allison. My voice as it comes across, and I'm sorry, we tried to fix that technically, but not going to happen for this presentation. Also, just kind of up front, want to say that kind of everything in this presentation is subject to change. This is, very early to be talking about the 2019 code, but I think it's also important, and that's why you've all signed on. You think it's important too. So it's all early. It's all subject to change. There's still, if you don't like what you see or you like what you see, there's still stakeholder meetings coming up that you can get involved and influence what 2019 looks like. So I just want to say that. Also, probably won't be talking a lot about all electric. This is going to be pretty general gas electric type homes specifically at this time. So just to let you know, the California Advanced Homes Program, just doing a little bit on that. This is the residential new construction rebate program offered throughout the state. Actually, we administer the one from PG&E, and this is all funded via way of the CPUC, California Public Utility Corporation Committee. Sorry. To be in the program, there's some basic requirements, and those requirements and entry points into the we plan on April 4th to announce the changes to the CAHP program, so please stay tuned. We'll send out another announcement about that soon. We're getting away from the 44-48 entry score and moving to a Delta EDR of 3. Stay tuned for more information on that. It's coming in 2 weeks. All right. So I always like to talk, when we talk code, talk a little context for the code, what it is, why it is, and all the great work we've done so far, just to put a little things in perspective. If you listened to this 2 weeks ago, it's going to be a repeat. If you didn't, it'll be new. All right. So just a little history of the curve of the code, established about 1975, or the CEC was. First code went into effect in 78. But when it was established in 1975, it was fairly tumultuous time in the United States socioeconomically. A lot of fear about uh, oil and gas shortages, OPEC embargoes. There was a lot going on, and that was kind of some of the cauldron that ended up producing the CEC. And the Rosenfeld curve there on the right of the slide. I mean, I think that says so much about California and what we've done to manage our electricity use over the last 40 years or so. So that is so what that blue line is showing is that we have not increased the amount of electricity we use per person in 40 years, which is incredible if you consider how many more electronic devices we have now in our lives than we did in 75. Just computers and air conditioning and cell phones and internet and all that stuff is new. I hear some people complain that they want it to go down. I think it's a victory just staying flat, looking at the rest of the country. And where are we going from here? What's this graph going to look like in 10 years? Frankly, I don't know. Maybe staying flat would be good since we're bringing on electric vehicles, that are going to come into this. Buildings going to zero, but there's still a ton of existing buildings, right? So don't really know where it's going, but I think, pat on the back of the success of what we've been able to accomplish to date. There's always people saying that we're not doing enough. I'm sure we could always do more, but what we've done is, I think, pretty amazing. See if I can advance this. All right. So this is really, the three main regulated loads by the code. This is something clipped out of a CEC document, but just showing where we've saved energy and heating, space heating, space cooling, and water heating over the those 40 years, and where we're going. 2016 to 2019, it's a pretty small incremental change, but it's pretty big and challenging to get there. And that's really what this presentation is about, how we get from that stacked bar at 2016 to that stacked bar at 2019. How do we get there? But again, I think this is just signs of success of what we've all collectively on this call have been doing for over the years. So kind of the challenges with the code, I also like to just point this out because, and I'm sure people on this call maybe, or I'm guessing they understand this a lot more than most people when you speak about the energy code, but renewables are great and all, but the main one we have is solar PV, and it's so variable. This is the 24-hour. This is 1 day in time. This is in January, so during a winter storm. That blue line is wind power, and so it was a very windy, very rainy storm that day, but we still had a peak of about 5,400 megawatts of electricity produced at the peak, but we had to rise and fall really quick. This is from, from Sunday. So that went from 54 peak to a 78. 78 was a mostly cloudy day, at least in Northern California. The other thing you really notice is the wind really was calm compared to that other graph. So it's this variability that is such the challenge in the grid now in California, and managing these spikes and variability is the real challenge, and the biggest one to manage is the solar PV, because this solar PV that's shown on the screen now does not even include what's on people's rooftops. This is only the renewables that are utility scale provided by the IOUs. So it's actually it's bigger than this. And this is if you take what the solid blue line is the actual demand, the dotted is the forecasted demand. And then the green is the net demand. So if you take out that solar contribution or the renewable contribution, that's what it looks like. That was that day in January, and this was Sundays. So the real challenging part is, is going from here to here, because what that means is, you've got to ramp up or accelerate the delivery of energy. You're really not accelerating, but you've got to be able to accelerate bringing on more energy generation onto the grid while the sun is setting, and then take it off when it's coming up, actually, as well. So this curve is known as the duck curve, right? Like this slide here is kind of a more general curve and where they expect it to go. This is actual from Sunday. It's pretty interesting. You can go on and view it instantaneously, like where we're at right now. But this duck curve. This is what where the code is becoming much more about helping to manage this duck curve than it is about energy efficiency alone. And that's really what we'll talk a lot more about that in this presentation as well. But as you've seen, as this graph, so this must have been done around 2013, and this is the very idealized graph that you've seen, or chart. As you see, here we are, and this is pretty close to what we see here, right? So this is the net load on March 31st, and that day is kind of chosen because it's a day where there should be very minimal heating or cooling anywhere in the state. So kind of the ideal, the best case scenario, if you will. And this duck curve is going to be exacerbated. So this is now the makeup of the energy that's being delivered onto the grid now. And 28% of this is renewables. And of that renewable, almost half of that is solar. Well, there's, it's called RPS, Renewable Portfolio Standards. And so all the IOUs have goals to meet certain renewable portfolio standards by certain years. And one of those is like a 50% requirement. There's a 30% requirement by 2025, maybe, or maybe, can't remember, maybe 2020. But it's going from where we are now up to 50%. So that duck curve, the back of the duck is just becoming, will be aggravated even more by the renewables that are coming onto the grid. Yeah, I guess that's it, right? We're going to a 50% renewable portfolio standard, right? So what this does, the more solar that comes on, it lowers the value of additional energy generation. So it makes solar on your rooftop less valuable because the IOUs already have essentially, so because it's already bought and in place, pretty free electricity at that time of the day. So it makes rooftop production less valuable. And it also affects the TDV values greatly as well. So let's pause here before we go to the next slide. I just want to check in with Allison. I feel like I'm going pretty fast on this, but are there any questions out there? I hear no Allison, so you may be muted, or there may just really be no questions.
Sorry, I was muted and I didn't realize. We have some comments, but not any questions so far.
Okay.
If you just want to speak up a little, if you can, Scott. I know that we've addressed your.
Yeah. Yeah, I'm doing what I can here, but I'll try.
Yeah. Okay, thanks.
Yeah, I'll look at all your comments later, for sure, and get back to you if you have any questions. So, so with all this solar that's coming onto the grid, what this really looks like is that the TDV values are shifting. So TDV, time dependent valuation, it is valuing energy at different times of the day, right? So this is the 2016 TDV values now, kind of looks like a camel. And the 2019 values are shifting to look more like a unicorn. The best analogy I can come up with. Now this is climate zone 12 residential TDV values. But what this is really showing is that, the time of the day. So the TDV starts to spike, what about, really any time after noon, right? But noon, 1 o'clock, 2 o'clock, this is our peak all the way down to 8, 9 o'clock. Well, now all of that spike, largely because of the solar on the grid, it's being kind of squished over into this unicorn. So now our TDV values really don't start to take effect until 4 o'clock, and then really hit their peak, around 6 o'clock, 6:30, 7 o'clock, somewhere in there. So what this means is, a lot of energy consultants on this call is that we've got to, the most efficient way to get your building to comply is to save energy right at that peak, right? If you can save energy there, that's the easiest way to get your building to comply. So, so it's just that shift is reflected in the code and how we're going to address it, right? Part of that with the solar PV, in time batteries are going to come in, but they're saying batteries are not there for 2019. They're not showed to be cost effective, but they are being written in. We'll talk more about that. But this shift in TDV values is fairly dramatic shift in TDV values. I remember forever we used to talk about that peak, 4 to 8 p.m. or something, right? So it's just being shifted out. And then won't spend much time on this, but of course I just always remind people, don't forget what climate zone you're in. It matters a lot. And what we see in the 2019 code when we get there is there's much more segregation in the climate zones. So where, walls in 2013, there used to be one, I believe it was one prescriptive standard for all the walls in California. In 2016, now there's two. So depending on where you're at, there was a different R value for walls. In 2019, now we're splitting it into three because we're getting the code, the buildings, the energy use is kind of death by 1,000 cuts now, right? So we just have to keep kind of honing down. So this is 2016 code home, but it's just showing kind of the energy use by energy use by end use by climate zone. So I just think this is just complements the climate zone slide well. Understand whatever building you're working on, how it uses energy, and address it appropriately. And that's all I'll say on that. And I'll pause for questions if you got any.
Nope, not at this time.
All right. All right. So ZNE. So what happened to ZNE? Because, we used to have this slide, and ZNE used to be called net TDV energy. And then, most of the people on this call know what TDV is. But the next question is usually, well, what is TDV? Well, now we've kind of went back to this new definition of ZNE in 2019, and I don't know if they're going to call it ZNE or ZN something else, but it's zero net kilowatt hours so zero net site electric for the year. So it's a shift in the definition of ZNE, and it has, there's a lot of repercussions here, right? So you're not, before, the old definition of net TDV energy meant that you, ZNE at zero TDV energy meant that you had to produce as much energy as you consumed in TDV, and that included gas. So now, this new definition excludes gas. So it makes the amount of solar that would have to be put on a house smaller. What it also means is, it's also excluding is TDV. And now it's just site kilowatt hours, which again makes the size of the PV on the rooftop, that requirement generally should go down. So this is kind of the smallest version. From zero net TDV energy, you got rid of the gas, the PV got smaller. Now you got rid of the TDV, the PV got smaller. So it's different. One of my concerns, and I'm not sure how this is going to be addressed, is from an environmental standpoint. I think most environmentalists don't like the use of gas anywhere in a home, but because you don't have to size your PV system to make up for the gas usage, this new definition almost incentivizes you to put more gas into a home. And we don't know how, this 2019, we don't know how it's actually going to fall out in the end, but hopefully there's going to be some mechanism there, because we don't want to be running our air conditioners on natural gas and stuff in the future. I can't imagine that would ever happen, but anyway. So this is kind of the new written out definition of ZNE. I just took the old one and just basically took out the words that make it new. So like I said, I don't know if this new ZNE definition is going to be called the new ZNE definition, or whether it's ZN little e or ZNE squared, or I've seen it called zero net, or zero net energy. No, net zero. Yeah, it's called net zero. So I don't know what it's going to be called, or whether we'll just all change and this is the new ZNE. This is kind of the rewording of the old ZNE to make it fit this new definition. Hearing nothing from Allison, I'll keep going on. So the grid, kind of, this is, some of this is certainly out of a presentation provided by Mozzie at the CEC. Some of this is straight out of his stuff. Some of it's from other sources, but this is one of those from Mozzie at the CEC. Changed it around a little bit, but if you talk to your neighbor at the mailbox, they, and you talk about energy efficiency, they just think, well, why do we even care? Let's just put PV on, right? And I think a lot of people, including some state officials, thought that too, right? Like, let's just put more PV on. That's the solution. But that's assuming that the grid actually can store that energy, right, when the sun goes down. But you can't store. Right now, the grid cannot store energy. Yes, Tesla is doing battery packs, and there was a new humongous one that I think just went into SCE recently. But in general, the grid's not set up to store energy. So all it can do is move it from one place to another. So the sun and how that moves is the grid just can't be used in the same way the sun is producing it, I guess. So where we're kind of getting all this is where we're going. Is this is so much of the code is moving away from efficiency, and efficiency will never go away, and efficiency will be improved in 2019 and beyond. But it's more than just efficiency now. It's called grid harmonization, and that's where we've got to get to, is this grid harmonization. Because this is kind of that duck curve again. The blue, well, the green is the rooftop solar. The blue is the total system demand, total demand, and then the gray is taking out the IOU generated energy. So kind of the same thing, but this grid harmonization now is going to have really 4 legs. So code moving forward will have 4 different things. It's going to be looking at efficiency, right? Like we always have. It's going to be storage, and that's storage is there may be many ways to store energy, but I think the most obvious and the one right in front of us is batteries. And then how do do we all have batteries in our garage? Is there, does each city have a field somewhere full of batteries? Like kind of, is it distributed batteries? Is it community based? Is, where are those? So storage is going to have to be addressed in some response or in some manner. Demand response is going to be the other one. Although every time I've heard, they say demand response is never coming to residential. It's just the loads are too small to worry about it. And we'll see. And then, of course, the other is renewable energy, which is, almost always going to be PV in our conversation, at least a non-utility scale. So this grid harmonization is going to have these 4 components moving forward. And efficiency is about really, efficiency, you can save energy all throughout the day, but it's about that peak, right? That TDV peak, and this peak lines up pretty well with that peak that we saw earlier on the TDV spike, right? So efficiency is about taking this peak and just trying to shave it off, right? And you can shave off anything, but that peak is the most valuable, right? That's efficiency. Can lower the whole thing, but storage is really about at this spot now and throughout the day. Storage, we should be putting energy into our batteries, filling the batteries up at this time of the day, so that later on in the day you can expel the energy that's in those batteries and apply it at that peak, right? So it's shifting energy. And really, battery storage is typically won't be storing it long term. It's just storing it through the day. And the net effect is you're going to, kind of the same thing we saw with efficiency, you're going to just shave off that peak. And then demand response, even if it's not coming into residential, basically just flattens it out. I don't have a problem with demand response. I think it can work in residential, but yeah, maybe there's just not enough savings there for the utilities to really get involved. But it's just shaving off that peak.
Scott?
Yep.
Can we go back a few slides and just go over the definition of ZNE for the 2016 code, just to clarify?
Yeah, so the definition of ZNE for the 2016 code is this without the strikeouts. So 2016 ZNE is a zero net TDV energy. That's this one at the very bottom. Zero net TDV energy. So zero net TDV energy means that you produce a time-dependent value of energy equal to all the electricity and all the gas used on site throughout the year. And the new definition is just getting rid of gas you take that out, right? It's just the net amount of energy produced on site is equal to the electricity consumed, not the value of the energy consumed. I guess electricity was added, but yeah, ZNE as it stands, and ZNE as it stands is for 2016 is probably not relevant anymore. The 2016 definition of ZNE is just not that important any longer, because because we're not going for it in 2016, but it's changing for 2019.
All right, thank you. That's all for now.
All right. So this is another one kind of out of Mozzie's presentation, but you know, to really go towards ZNE, we want to encourage envelope efficiency, appropriately sized PV. It doesn't do a lot of good to produce a lot of extra electricity. Grid harmonization and EV integration. So grid harmonization is just what we talked about. EV, electric vehicle integration. And then hopefully the 2019, you know, of course, the code is always trying to create competition and innovation into the industry. All right, so I mean, what the pictures are just kind of depicting. Home energy management systems kind of should be tackling the non-regulated loads, batteries, as we talked about, and heat pump water heaters. This is some of the innovation that's coming, not in the 2019 code, not mandated. The heat pump water heaters are real and are being produced now, but not required in the code yet. All right. So the building standards, basically, just kind of where we've come, the savings amount per year. So 2019, that step is supposed to be about another 15% improvement over 2016, which is a 28%. So it's going fast. Mandatory. So most of the changes in 2019, all the changes I've seen so far for the prescriptive packages, not the mandatory packages. So the nitty-gritty for what these changes really are. Okay. Major changes to the 16 code or in the 2019 code. So this is the wall assemblies. So the wall assembly is saying that we've went from a 0.151. So right now, we went from a 0.065 in 13 to now a 0.051 everywhere except for 6 and 7. And now we've increased this to a 0.043 in climate zone 1 and 11 through 16. And this is what I talked about, where climate zone matters, and the code is becoming more pointed in its prescriptive requirements. And again, this is prescriptive. But yeah, 0.043 is in our 23.3. So the walls are taking another big step. And you know, one of the reasons why I like talking about this is that we can't rest in what we do. We have to be encouraging our customers and our clients and the builders out there to do more walls, to do better walls, to get it into their work scopes, and it's not really there right now in what are we, March of 2017, but they're just getting tougher and they're not going away, and so we need to get there. And just to be clear, you know, this R23.3, this is not the insulation inside the cavity, right? This is the insulation. This is the assembly U factor of the entire wall. And so, you know, there's a lot of different components in the wall assembly. They each have a small bit of R value, just even the air inside the house is considered some of the wall value, right? Or the adds to some of the U value. So again, this is assembly U factor. This is the prescriptive, and it's not a mandatory requirement. Prescriptive, again, this is what your building will be judged against. The PV credit right now trade-off is an easy out for a lot of builders, but it's going away. And so all of these wall assemblies are going to have some foam on the outside. What type of foam are you going to have? This is just showing kind of the three more popular: the expanded polystyrene, extruded polystyrene, and polyisoisannurate. But there's others out there. They all have different R per inch values. But I mean, really, when we get down to it, going to a 0.043 R value is getting to be a very thick wall, right? It can be done in a 2x6. There's a few ways to do that. 2x6, 16 on center, R21. That's a high density, plus an exterior of an R7. R7 should be somewhere between 1.5 to 2 inches of exterior in continuous insulation. Depends on what that continuous exterior insulation you choose to be. But it's becoming big, right? You can still do it in a 2x4 wall, 16 on center, R13, but now you've got an R12 on the outside, so now you're talking like 3 inches of foam on the outside. I think that's, in most people's books, unrealistic. Although even the R7 or the R8 may also be unrealistic to people, at least where their thinking is now. I think it's doable. I've built that way. You can get there, but this is just some of the assemblies. Other ways to do this is, you're going to be going to a 2x8 or some other wall assembly. Right. So this is just straight out of the reference appendix, 0.043s. On here and better, so anything to the right of these. I don't show a lot of this table, but you can look it up and see what other wall assemblies would work in your climate zone, and it all depends on your climate zone, right? What's required. And then, at what point do we stop building walls with 2x4s or 2x6 or 8, whatever, 2x's? At what point do we switch to a better wall assembly? Allison, you got anything for me? Any questions before we move on? The attics?
Nope, go ahead.
All right, so attics. The changes to attics in the 2019 code, 2013 we went from vented with the ceiling insulated, no insulation at the roof. 2016, now we added this crazy high performance attic, and this slide is kind of based off of high performance attic option B with bat insulation. In 2019, though, now we're going from an R13 under roof deck to an R19 under roof deck insulation. So, it's not going away. Let's learn how to build this way, or, throw it all out and figure out how to build better so that, maybe ducts and conditioned space are real. Maybe that's how we need to be building all of our buildings. Maybe then it becomes cheaper just to do it that way, rather than put them in a vented attic. But for high performance attics, HPA, now, so there's still A, B, and C, right? A is still the insulation above the roof deck, B is insulation below the roof deck, and C is in conditioned space. But now we have two option Bs. And again, this is like 2.5 years, right, before this becomes real. So all of this may change maybe we're going to have option A, B, C, and D is ducts and conditioned space. But kind of as the thinking is now, this is what it looks like. So if we just look, the most common is option B. What this is saying is you're going to an R19 again, but not in every climate zone. So it's just going to be a few climate zones that are going to the R19. That's climate zone 9, and then 11 through 16. And then also, or that's if you're doing the high performance attics option B with bat insulation. But if you do like the box netting, and I don't even know if that's like a trademarked thing of Owens Corning's, but the box netting, so you don't have to put as much insulation there. And what this is taking into account is that you're getting the thermal break from when you do box netting. And then, above deck roof insulation, which I think is not as popular a choice. None of these are popular, but A is probably less popular. The R value is going from a 6 to a 7 in those same climate zones 9 and 11 through 16. So just tweaks, right? And then the high performance windows, HPF for fenestration. Not a huge deal, but they haven't changed in a couple code iterations. So 3225 to 3023. I think 3023 is a pretty simple change to be had. So I don't think that's going to cause heartburn for too many people out there. Where the code is going beyond this, though, is what they've asked, or what we've been talking to them about, is how can we really incentivize Windows? And we need to take the next technological leap in Windows, because at this point, when you've got R20, R23 wall, the heat loss is through the windows. The windows have always kind of been the weak point of the envelope. When we went from single pane to dual pane, it made a dramatic difference, right? There's still a lot of single pane buildings out there that, when you model those with the change to dual, it's pretty dramatic now. Well, now we need to get even better on our windows. And, I've seen model runs with a U factor of 0.2, solar heat gain of 0.2, or a U factor of 0.15, a solar heat gain of 0.15. It's really challenging, right? Like that technology of window does exist now, and I hear like that's kind of where passive house is right now, but the general market is not there. And so how do we make the next technological leap in Windows to get from where we are now, which is around the 0.3, 0.23, 0.25, where do we get from there to get down and cut a third of these out, a third of this, so you're at 0.2, 0.2, or 0.15, 0.15. How do we get there, and how do we move the market to do that? So that's so for 2019, it's not a big step, but Windows will continue to be an emphasis, especially in cooling dominated climate zones, such as the Central Valley, where, these numbers are high. We haven't done independent verification of these, but just some numbers we've been shown. So Windows are one of the new frontiers. So the packages and what this kind of looks like now for 2019. So, high performance walls are going to decrease energy use 2 to 4% or so. Attics are going to do another 1 to 3, and windows another 2 to 4. So altogether, the packages are looking like, if just those three, walls, attics, and windows, what's 7 to 10, and these are in, just a few climate zones. But the other prescriptive path forward, the other option is to make QII the prescriptive standard in the code. And I'm been working with QII for a long time, and I know it well, and I know the challenges in the marketplace. But the QI seems to really scare a lot of people to make that the prescriptive standard. Again, it's prescriptive, so it doesn't have to be done, but that's what your model's being compared to. And if we add QII to that prescriptive standard, at least in the Central Valley or mostly Central Valley climate zones here, certainly the large cooling load climate zones, we're getting, what's 13 to 18% better than the 2016 standards. So it's getting there. That PV compliance credit is going away for 2019. So we've got to wean ourselves off of that. And I don't know that there's going to be any weaning as long as it exists in the marketplace, and it's the cheapest way to do it. I don't know that anyone's going to be looking at anything else, but hopefully some forward-thinking builders out there, and I know you exist, are figuring out walls and attics, and hopefully can start thinking about this 2019 walls and attics and how do you get there.
Scott, we did have a question going back to the attics. Can you explain box netting assembly at roof?
Ooh, I don't have a picture of it in this one, but I would guess if you Google box netting Owens Corning, it'll come up. But what box netting is it's a netting that's stapled to the underside at the roof, where it's stapled to like the top truss cord, and then it hangs down and it goes over to the next top truss cord, and you staple it again. So and there's a couple it's sewn a couple places in there, so that it creates like a box basically. But what it does is it do I look for it real quick? Let's just look real quick. It's a small audience, and this is kind of out there. Let's box netting. Let's ad lib a little bit, right? Yeah. So this is really what it looks like. That's another picture too, but it's just stapled there. It's just a box that goes over. What happens then is the installer like pokes a hole in it and fills this cavity. So the top of this up here is the roof sheeting. So then this whole cavity is just filled continuously with insulation. But the big advantage here is what you get the thermal break between this and wherever the end of your insulation is. So you get shoot, that's not what I want to do. But you get the full cavity. You get this thermal break here is filled. So that's box netting. There may be other manufacturers. I'm not aware of it, but that was just kind of new in the code.
All right, thanks. Those are all the questions for now.
All right. Where are we at? All right. So the last thing that really it's in the code now, and this is, I should go back to presenter mode and swap. Okay. So the target energy design rating is something that's going to be new. And right now there's a few EDRs, energy design rating, and there's a standard design EDR, and this is the EDR of the building using the prescriptive requirement. So this exists right now in the 2016 code, and I would recommend you all, whether you're in CAHP or not, to start paying attention to your EDR, because percent compliance will matter less than your EDR in 2019. But there's a bunch of different EDRs. There's the standard design EDR, and that's just your building using prescriptive requirements. There's proposed design EDR, which is your building, right? And it's the EDR as the building was designed with performance trade-offs, and that's without factoring any PV into it. And then there's a proposed PV EDR. And what I see in 2016, and I'll show you a slide of this in a minute, or 2019, is this could be a proposed PV plus battery EDR, and they're going to be giving some EDR, assigning some value to batteries and how that affects your EDR. So you'll get a PV, and that's just an EDR for the PV system itself, and then you'll get a final proposed EDR. And so, yeah, there it is. So this is the final EDR of the home as designed, and that takes PV into account. So that's like the entire home now into one number. And so if you're participating in CAHP, we are using EDR for program eligibility. Like I said, in 2 weeks, we'll make this official, but it's going to be a Delta EDR of 3. So you're going to have to be 3 better, and that's your standard versus your proposed is going to be 3 better. And then there'll be some kickers added to that as well. But EDR is important. These are in the 2016. What's new is that for code compliance in 2019, I probably should have that on here. But anyway, 2019 code compliance, now it's not going to be about just passing some energy budget, kBTU per square foot per year. It's going to be, you have your proposed design EDR has to be less than the standard design EDR. And your final proposed EDR has to be less than or equal to your target EDR. And so your final proposed EDR is that combination of efficiency and generation. So one number is, you're no longer going to make the building comply. You've got to comply to both. You've got to comply to just making the building efficient first, and that's this first kind of bullet point up here. And then you've got to add enough solar to, or you could do it with efficiency. That's the thing. You can do either one to get the. But you've got there's 2 things you have to meet to comply to code now, and it's those 2 main bullet points. So you got your design EDR, how the building's designed. That's your proposed design has to be less than your standard design. And then you're going to have your target EDR. And how do you get there? You can either, you can do it with PV or more efficiency. Most likely it's going to be some combination of those. And that's going to be the value engineering is, you know, do you add more efficiency to the building or do you add more PV to the building? Now, again, these solid green ones, these are like minimum thresholds, so you can't just throw a bunch of PV on and get the house to comply. The code does not allow that, and PV offset credits going away. So you're still going to have to meet your design EDR requirement, but then this target one, you can do it with either efficiency or PV. And I want to just pause there. To me, it's a little difficult to understand, but there's just going to be 2 thresholds for code now. So how that's going to look this is a screenshot of CBEC, the kind of the beta version they're using now to test some of these packages. But what this has, so this is, again, your standard design EDR. So this is going to be, you've got an EDR 47.3. That standard design is the house with prescriptive measures. And then for this one, it's saying the proposed design is a 43. So that's the home as you wish to build it, and making the performance trade-offs. So this here complies. Now it's going to calculate another EDR of proposed PV and batteries. And so now we're showing a 20.8 here for that. And then this final proposed is the target EDR, right? So that's telling you where you're going to end up. So going back to this new definition, 2019 definition of ZNE, is that you have to produce as much electricity, site electricity in kilowatt hours as you consume. What this is showing is that PV is creating 4,800 kilowatt hours, and that net effect on this house for the year is a -19. So the building complies because here your proposed design is better than your standard, and your site kilowatt hours is better. But right now, the way the code's going to be talking about this is more target EDR and design EDR. But the target EDR will mean that your site kilowatt hours has been zeroed out for the year. And I want to pause to see if there's any questions. I think that's somewhat confusing.
Not yet. I'll let you know if any come in. Okay. Maybe they're typing right now.
Okay. So the target EDR example, so this again, just straight out of the CEC. So what this is saying is that, so this is going to be like, this is just some runs of buildings, and there's going to be a efficiency EDR that's going to, so this is based off the prescriptive package. The building's going to have to do at least that. And then the target EDR is going to be, so let's go to climate zone 12. That's where I'm standing now. So efficiency wise, the building is going to have to be at a 43.2. And then the target design rating is going to have to be at 22. And how do you get from 43 to 22 can be some combination of efficiency or generation. Like I said, probably PV. And now the code, and I don't know how it's working, but batteries is going to be also helping your EDR score in some manner. So you can get from 43.2 once you qualify there. Now you got to get to 22.2, and that can be some combination of efficiency, PV, and storage. And this is just kind of showing about what size PV panels anticipated in these climate zones. So about 3 kW. All right, we'll keep chugging along then. So the advantages of this target EDR is it establishes a performance benchmark. And so the hope is that there's, again, the code is not completely prescriptive, it's flexible, there'll be other ways to navigate through the code. It does allow builders to figure out what's best for them between efficiency and PV, and for that matter, batteries. If we're going to get credit for that, even though it's not going to be written into the code, it looks like we may be able to take some credit for batteries. Stay tuned. And then hopefully the demand response can be the battery piece of that. Flexibility, storage, grid harmonization strategies, right? All of this code stuff is about grid harmonization at this point. And the EDR should work well with varying building sizes. And that's really why, like CAHP and the future CMF&H program, those are all coming out in the next few weeks. They're all working with a delta EDR of 3. So recognizing the EDR is really where we're going in the future. And a delta of 3 is reachable in all climate zones through various ways. But EDR is where we're moving into the future. And then that's really it. Unless you have questions, I will want to just say, don't forget, Energy Code ACE is out there. It's a great resource. It's free. I also want to say that all these codes, again, all subject to change between now and when they go live, and hopefully January 1st, 2020. There's still time to get involved. There's stakeholder meetings that you can attend by webinar to get these updates as they come out. There was a meeting, I think a week ago today, about all of these, and you can find out more. You can participate, make your comments heard. Encourage you to do that if you're vested in this, and you have the time, right? So that is my presentation for today. So if you've got any questions, speak now, or you can email me at this email address, and I'll do my best to answer them.
We did have a question. Is changing the ZNE definition an attempt to meet the state's 2020 ZNE goals? And if so, when can we expect gas appliances to be targeted in the code?
I'm not able to speculate on this changed definition of ZNE, and I've never heard anyone actually kind of just flat out say that they've changed the definition of ZNE. And I think my guess is trying to not make it sound, not make it sound like a kid who's losing a game that just changes the rules so that they win. I have young kids at home, and that happens a lot. And I don't think that's what's happening here at all. I think that they're recognizing the impact that PV is having more and better and different now than they were 3 years ago. So the ZNE 2020 ZNE goal is shifting, and I think from what it looks like, it's shifting to this new definition, and that a true ZNE, a time-dependent ZNE that includes gas, may not be what's best for the grid right now. But I don't know how, again, I fear what this means to gas, because it would, if you put more gas in, you have to put less solar on the roof. So that's the way it's looking right now, and I trust that they know that as well. I'm sure they do, and they're working towards some solution on that. But I don't know what it is right now. It's a good question.
All right, one more. Will the credit for battery storage be dependent on the size of battery, if you know?
The only thing I know about it is this one screenshot out of somebody's where it just added that plus battery right there. And I have nothing else, no other information at all. I don't know what that plus battery means. I mean, I'm sure it's going to depend on how much storage, but I have no idea how it's going to be calculated into the EDR at this point. But I'm just encouraged that at least it's there, and maybe we will be able to use it in 2019 and get some credit for it. I have no idea what that looks like right now, though.
All righty. That's it for now. So I just want to remind everyone that you can reach out to us with any other questions you think of after the webinar. We will send a follow-up email this week with the link to the recording and slide deck, so you can reply to that as well. And thank you for joining us today.
Thank you.